Today we talk about the performance evaluation of CPU. So in an ideal situation, one has a suite of programs whose instructions mix is known exactly. By running each program on a processor to be analyzed, it is possible to determine the it is possible to determine the CPI cycles per instruction for each type of instructions, right? So, however, life is rarely ideal. So, thus we have the some types of benchmarking programs to measure and bound processor performance. So, what are those benchmarking programs? So, first, see the synthetic benchmarks. So, which are used to these synthetic benchmarks, which are used to exactly measure specific characteristics of a processor, such as your uh, the memory input output performance, register to register input output, or speed of an arithmetic functions, etc. So that is because the benchmarking program is synthetic. One can put any combination of instructions into it, and the benchmark is not necessarily realistic. The second one is we call toy benchmarks. So these toy benchmarks are simple but somewhat realistic programs that help the designer get a preliminary idea of how a processor will behave under a pseudo realistic constraints. So these might include tasks such as solving a simple matrix equation or performing nearly a trivial image processing operations. We call them as your toy benchmarks. And another evaluation is kernels. So these kernels are more involved programs that capture the functionality of a larger program. So for example, you can see one can use a operating system kernel to get an idea of the operating system performance on a given processor, which provided that the kernel is executed significantly more in practice than the other programs in the operating system. And the another benchmark, or type of benchmark, we call the real programs. So these real programs are used to perform at many stages of processor design is one, and second one is to estimate the processor's performance under realistic computing constraint, and third one is in assessment of your fielded system. So these are four benchmarks which are used for the performance evaluation. So in practice, realistic benchmarks include engineering or scientific applications, software development tools, transaction processing, and office applications such as large spreadsheets or formatting of word processing documents. So this we call the performance evaluation. So what are those in performance evaluation? As we are saying that, so we have some types of benchmarks. These benchmarking programs to measure and bound the processor performance. One is your synthetic benchmark, another one is toy benchmark, another one is your kernels and real programs. So then comes to your performance reporting, how this performance will be reported. So after one has measured the performance of a given processor, then one formulate a test report. So in order to make our report accurate and meaningful to a hardware designer, we must have at least three elements in the report. So that is the first element we call the hardware software configuration. So this hardware software configuration tells the designer what benchmarking program, whether it is a synthetic benchmark or whether it is a toy benchmark, whether it is a kernel, whether it is a real programs. So that is, this hardware benchmark tells the designer that what benchmarking programs were run on the processor under test. So and how the processor was set up and how the processor was set up. So example, how much memory and what clock rate, how much memory and what clock rate and what is the compiler version, etc. What is the compiler version, etc. And another element for performing report is your evaluation process conditions. So evaluation process conditions provide the information about special constraints on the instructions mix that can influence the reproducibility of the performance measure. Reproducibility of the performance measurement. And third element is performance summary. Performance summary. So this performance summary is typically expressed in terms of average rates. Average rates. So how these average rates are computed is of your practical interest. So practical interest. So for example, let us see consider these following types of means for averaging the for finding the average rates. One is arithmetic mean. Arithmetic mean. So the arithmetic mean will be given as 1 divided by n. 1 divided by n. It is multiplied by the execution time. Execution time. And another one is harmonic mean. So this harmonic mean given that n divided by summation of your 1 divided by your clock rates. Clock rates. And weighted mean. So this weighted mean will be given the summation of how much weight you are giving to a particular application to execute. So for that, suppose if I have 3 applications, 1, 2 and 3 applications, if first application is taking a lot of time, execution time suppose 10 seconds, second one is taking only 2 seconds, third one is taking suppose 10 seconds, then if you are giving the importance weight to the third one first, then the weightage will be given to this one. Then the next one, then the next one. So that is the weighted mean, and then another one is geometric mean. So normalized results are not easily understood or accurately compared with the arithmetic mean because the mean of ratios between two series of measurements is not the same as the ratio of the series means. So instead, normalized results should be combined with the geometric mean, so which is independent of the data series used for normalization. So this is because the ratio of two series geometric means is the same as the mean of the ratio between the series. So that is, suppose given two data series, for a given two data series, suppose if I have a series like AI, data series of AI, and your BI, data series of AI and BI, where this where your I is equal to the number like 1, 2 up to n. If the arithmetic mean is used, then if the arithmetic mean is used, then we write this as for this arithmetic mean we can write this the arithmetic mean of your AI the arithmetic mean of your data series AI, which is divided by the arithmetic mean of your BI data. So this is not at all equal to the arithmetic mean of your uh, AI divided by your BI. So arithmetic mean of your data series AI divided by arithmetic mean of your data series BI is not equal to your arithmetic mean of your AI divided by your BI. So whereas the geometric mean, this in geometric mean, you can write it as is as, suppose, the geometric mean of your AI, the geometric mean of your AI divided by your geometric mean of your BI, the data series BI, the geometric mean of BI. This will be equal to your geometric mean of your AI divided by your BI. AI divided by BI. Okay, so that you can see the results. For example, here the we construct here we construct the result. Suppose the AI divided by your BI. Suppose here we construct this AI means, this means divide the ith element of your A data series by the ith element of your B. So for example, if I have the element support data series AI is equal to some data series like 2, 4, 6, and BI data series, suppose if I am having suppose 2, 2, 3, right? So then to compute this AI divided by your BI, it will give you the result that 2 divided by 2, the ith element of the first element of your A and first element of your B, comma, the second element of your A divided by second element of your B, and third element of your A divided by third element of your B. Okay, so that gives the results. So in this, but if you compare these results with your AM and your the GM, that arithmetic mean, and in your geometric mean, in arithmetic mean it will not give you the same value, but whereas in the geometric mean it will give the same value. So this is the performance reporting. As said, this performance reporting, I'll repeat again. So this performance reporting consider the three elements. One is the hardware and software configuration, or evaluation process conditions, and performance summary. So in performance summary, it finds the average rates. So these average rates can be computed with the practical interest of arithmetic mean or harmonic mean or weighted mean and geometric mean. But as said that the normalized results are not easily understood or accurately compared with the arithmetic mean, because the mean of ratio between two series of measurements like AI series and BI series is not the same as the ratio of the series means. So that is what we observe. So if you apply this, if you take this example and if you apply for this the arithmetic mean of your AI, arithmetic mean of your AI. So, how you will get the arithmetic mean? There are three elements. So, you will get 2 plus 4 plus your 6 divided by 3. That will give you that, 12 divided by 3 is equal to 4. Similarly, the arithmetic mean of your BI, if you take this, there are three elements, that is 2 plus your 3 divided by your 3. So that will give you that 7 divided by 3. So it is almost, some 2 point change. It will give you the result. Uh, 2.33. So if you recall the function, that if you find the arithmetic mean of your AI divided by your BI, arithmetic mean of your AI divided by BI. So if you find this arithmetic mean of this AI divided by BI, so how do you find here? The every element. So 2 by 2, you will get the element 1, and here is 2 ones are 2. So you will get 2 here. Here is 2. So if you calculate this, 1 plus 2 plus 2 divided by 3, it will give you 5 divided by 3. That will be equals to is your 1.66 changes. So here you can see the in arithmetic mean, that means your arithmetic mean of your AI elements divided by your arithmetic mean of your BI element. So if you get this result, then arithmetic mean of your AI is your 4, and arithmetic mean of your BI is your 2.33. So you will get the result like 1.716. Okay. So this is not equal to your arithmetic mean of your AI divided by your BI. So that is the meaning. What it says, the normalized results are not easily understood or accurately compared with the arithmetic mean, because the mean of ratio between two series of measurements is not the same as the ratio of series mean. So instead, normalized results should be combined with the geometric mean. Here the results are not same, so it will combine with the geometric mean. So in geometric mean, how it is calculating the geometric mean of your in the geometric mean, you are following the product, the execution time ratio, the execution time ratio. So the geometric mean gives the accurate value. So this is we call these performance reports, performance evaluation and performance report.